Hi everybody. Today we're going to spend our time learning about rectangles and squares, which, similar to a rhombus in last lesson, is also a type of parallelogram. So here at the beginning we have some review of what's special about a parallelogram. And you can see here at the top of the notes that a parallelogram has the top side parallel to the bottom side, top side congruent to the bottom side, opposite sides are parallel. Also, besides being parallel, opposite sides are congruent, and so on and so forth, the same 5 properties that we've been dealing with. However, a rectangle is a type of parallelogram. It has these exact same types of things. Top is parallel to the bottom, left is parallel to the right, top is congruent to the bottom, left is congruent to the right. Same thing with all the other properties, but with this additional thing, it is equal angle. And equal angle is a word we haven't learned yet, but it means something very obvious. All the angles are equal. So what that would mean is this angle here is the same as this second angle, same as the third angle, same as the fourth angle. And because they're all the same, they also have to add each of them equal 90 degrees. So it's not just that all angles are equal, it's that all angles are right. In other words, they're all 90 degrees. In addition, there's something special about the diagonals. In a parallelogram, diagonals bisect. One piece is equal to the other. Same thing, one piece is equal to another. It's the same thing in a rectangle. The top left piece is the same as the bottom right piece. The bottom left piece is the same as the top right piece. But not only are these two the same, also the other diagonals pieces are the same, meaning the diagonals are congruent. And then that means all 4 parts are equal. Compared to a rhombus and even to a parallelogram, rectangles are going to be a lot easier. And same thing with a square. A square is both equilateral and equiangular. There's a special word for that we're going to be learning eventually called regular. Don't really need to know that word right now, but I'm going to put it in there. And anyway, regular, it's just a fancy word meaning equilateral, equiangular, but it's equiangular, so it has all these 7 properties. In other words, it has the properties of a parallelogram, it has the properties of a rectangle, and the 3 rhombus properties. Not that we need to know those rhombus properties perfectly from last lesson, but a square has all 10 properties, the 5 properties of a parallelogram, the 2 properties of a rectangle, and the 3 properties of a rhombus. What does that mean? All right, turns out this is going to be a lot easier than some of the other things that we've been doing. So, 3 things we're learning today. First is far and away the easiest stuff we've been doing since all this distance learning. What are the angles on a rectangle? In other words, hey, how many degrees is angle A? Looking for a number. Well, all the angles are the same. All the angles are 90. Yes, it's that easy. What about in a square? How big is angle G? All the angles are the same because it's the same as a rectangle. All the angles are 90. Now the question would be, however, how big is angle GFE? Oops, sorry. I'm going to have to draw that a little differently now. Sorry about that. Angle GFE, this whole angle, not that part there. GFE in that corner is also 90. However, how big is angle GFD, this angle right here? Well, it's part of a 90, but it's less than 90. And if you stop to think about it here, just like a rhombus, the whole angle is divided into 2 equal pieces. Last lesson, you spent some time on IXL and problems where, like similar to an isosceles triangle, you would divide whatever the angles left over was divided by 2. Same thing here in a rhombus. You'll take what's left over, you'll divide it by 2, which gives you 45-degree angles. Turns out, absolutely, angles in a square often are 45 degrees. So the first thing is that you're going to see on IXL today is you're going to see them asking about angles. Often when it's asking about angles, it's going to be as simple as 45 degrees. But careful, this angle here is 90. So make sure you trace the 3 letters, HLK, HLK. Oh, that angle is 90, even though the partial angle there in green is 45. And then lastly, how big is angle HMJ here in the middle? Well, we didn't write anything today about the middle of a square and how big how big the angle is where those diagonals intersect, but it has all the properties of a rhombus we learned. And the rhombus properties are that diagonals are perpendicular. In other words, it's 90. We have a lot of 90 degrees on this page. IXL often goes with the 45-degree angles in green when it's asking you to find angles. But the first thing you're going to have to make sure you do is, hey, what angles in a square are 90 versus what angles in a square are 45? Hopefully simple enough. Easiest thing so far. Diagonals. We know that diagonals bisect. We also know that diagonals are congruent, meaning diagonals bisect, those 2 pieces are the same, and also diagonals are congruent, all 4 pieces are the same, EB is just 11. How big is DB? Well, this piece is 11, all the pieces are 11, so 11 plus 11, DB is 22. There will be some math where you have to take something and double an answer up. That's all we're doing here. What if it's algebra? Same type of thing as you've been doing for a while on IXL. Same thing as you've been doing since August. Oftentimes, things are equal. This piece is the same as this piece, is the same as this piece, is the same as this piece. All 4 pieces of diagonals are congruent in squares and rectangles. Therefore, just set them equal. Solve out your algebra 1. 3-step equation. Negative 4a plus 2 equals negative 22. And as you solve it, this one will come out to be 6. Excuse me for not showing every step, because it's small in space. Lastly, what if it gives you the exact same thing here? LM 2b plus 1, MK 3b plus 9. It's the same thing. 2b plus 1 equals 3b minus 9. When you solve this out, you get b equals positive 10. The only thing extra here is if it asks you to find things like HM, how big is that part right there? Well, the answer is it's the same as everything else. So plug your answer of 10 back in, and we get 21. Easy enough. Hey, what if it asks you to find HK? This whole distance here, 21 plus 21, the whole distance is 42, twice as long. So you're going to have some problems on IXL that will be this level, and what you're going to have to do is just make sure you know that pieces are equal, and if needs be, double them up. You may have to do some algebra problems, solve out the algebra by setting the 2 pieces equal, and if needs be, plug your variable, like we did for the last problem, b back in. I don't believe there's too many problems. You might have to double them back up again, but those may come up. Please read carefully, look at the 2 letters, like on the problem on right in green, HM in green was just a little piece, plug it back in, you were done. HK was the whole diagonal, you had to make it twice as long. Last thing of the day, what about sides? And the answer is easy, in fact, easier. Diagonals that we just did was the hardest part. Now the easiest thing here is, hey, how big is AD? I see the number 9, I see the number 17. Do I add them? Do I subtract them? Do I set them equal to 180? Do I subtract from 180? Do I do something with 90? Nope, none of them. Sides in squares and rectangles, the opposite sides are just equal. No problem. Sides in squares and rectangles, opposite sides are just equal. Really? Is it that easy? Yes, it is. Excuse me for not showing every algebra step. This one works out to 8 if you need to try it out. And the last one here, oh, wait a second here. We just did the left side's congruent to the right, the top side's congruent to the bottom. But wait, what about the right side, 9y plus 1, when I don't have the left side? I only have the bottom side. Oh, but in a square, and it is all the four sides are the same, because a square has all the properties of not just a parallelogram and a rectangle, also has the properties of a rhombus. So this is the exact same problem, slightly different looking picture. Solve this out. When you solve this one out, this one comes out to be y equals 5. And then lastly, it's asking for how big is hj. How big is this side here? Same as any other side. Just have to plug it back in. Doesn't matter which side you plug it back into, because all the sides are the same. And you're going to answer 46. So compared to rhombuses, which was harder, and parallelograms, which might have been harder, this one should be significantly easier. Yes, there's going to be some algebra to do. Yes, you might have to plug some things back in. But as you can see here, all you need to be able to do is set two things equal. If needs be, plug an answer for x or y or a variable back in. Set two things equal. If needs be, plug in a variable for x or y back in, or a or b, or whatever the variable is. Be careful with diagonal pieces. Just double check it wants you to find a small piece, like the first problem. When we got db equals 22, you might need to find the whole piece. And then lastly, possibly easiest, if it's asking to find an angle, like a single letter angle, like angle A or angle G, it's 90 degrees. Simple, no math to do. If it's asking you to find a three-letter angle, careful, it could be one of the 90-degree angles, or it could be a 45-degree angle. And if I remember correctly, IXL does a lot more 45s than 90s, but be careful. Trace the three letters, like we did in the last problem, HLK, that whole angle is 90, versus HLM in green is 45. Your IXL level today is level N.9 to a score of 90. Shouldn't be too bad. And I hope you guys have a wonderful day. Stay safe, stay social distancing. Please contact anybody here at the school if you need any help with anything, whether it's math related or just life in general. We're here to help you guys. Good luck, and talk to you later.